Okay, so focus here. Looking at variable basis. So we're putting all the work that we've learned, all of those rules, and now we're going to have more bases that are variables. Up until now, really each question, some might have variables, some might have numbers. Now it's going to be a combo. Come on, let's hustle. Hustle, hustle. Oh, when? Okay, so we have written out there on your notes all of the rules, so the exponent laws from junior high and the ones that we've just learned. So the ones that we've just learned are at the bottom, negative exponent and fractional exponent. So what we have to remember here, when asked to simplify, you must always leave final answers with positive exponents only. So sometimes we'll prompt you or we'll remind you, but sometimes we won't. So if we say simplify, we are expecting you to have positive exponents. Take a look at this question here that is with numbers, and it's the exact same question over here, but it has a base of x. So notice how you get 1 over 12, x2 to the 12, you get 1 over x to the 12. So you never do anything with the number base. If it's a coefficient, yes, you might, but if it's a base, you don't do anything to it. It stays with that same base. So the base of, let's see, here, says the base of the powers in the first example is 2. So you fill in that with 2. And the base in the second example is x. All of the same rules for exponents apply for simplifying. However, when we simplify powers with variable bases, we will arrive at an expression that involves variables, in this case x, rather than a number. Well, I'll put words variables, I guess, because it could be more than one. Now, what we haven't practiced yet is substituting values in. Right here, probably. So what we haven't practiced yet is substituting values into an expression. Key is, you could substitute the values in right away, but then you have a lot of calculating to do. It does say simplify first and then evaluate, so it gives you a hint. So we want to look at the coefficients and do whatever we need to. So this has a 6 in front. No coefficient in the denominator, so that stays as 6. Then we look at, are there a's in the numerator and in the denominator? If so, we're going to divide them, which means we subtract the exponents. So a cubed divided by a is a squared. So a big mistake some students make is they forget that the exponent on a is 1. If there's no exponent, it means it's a 1. So 3 minus 1 is 2. Then we look at b's. B doesn't have an exponent, so it's 1. And that would then be b. Negative 2 minus 1 is negative 3. I'm going to just do that division right away and then deal with the negative exponents in a minute. And then dividing the c's, we've got c to the 5th divided by c cubed, so we subtract those exponents and get c squared. So now, here's the deal. We did negative exponents the other day. We didn't do a lot with lots of variables. That's why we're doing this today, more practice. This is the only part of this that goes to the denominator. right? It's the only part that has a negative exponent. So the 6a squared, c squared stays in the numerator, and that becomes b cubed in the denominator. I'm just going to fix that up a bit. Okay, so now, so that's done. That's simplified. Now we have to substitute the values in. So we'll have 6. I put brackets where there's an A, put the squared. Brackets where there's a C, put the squared. Brackets where there's a B, put the cube. And then I actually substitute those values in. So A is 4, B is 3, and C is -2. So now it's an order of operations question. You have to follow the order of operations. I'm writing really big, so I'm running out of space here, but I'll go to the right. So now this is really 6 times 16 times +4 over 27. Then, what's 6 times 16 times 4? So 6 times 16 times 4, 384 over 27. Do you think I can reduce that without using a calculator based on those numbers?
I just have a question. How do we turn A, B, and C? Oh.
Do you think we can reduce that fraction? Yes. What do you think we would divide by? By 3. I can tell that back up here because 27 and 6 have a common factor of 3. 27 is not even, so I know that it doesn't go into 4 and 16. So if I divide top and bottom by 3, then what do we have? 1, 2, 8 over 9. Someone can check my math. Okay. So the odd time will ask you to substitute variables with numbers. The rest here, we're not doing that. We are just simplifying. Okay. So, got to think about the order of operations still. So you've got brackets. This is multiplying between the brackets there, but this is an exponent outside the bracket. So we have to do that part first. So that's, oh gosh, just a sec. That's multiplying there. So in this bracket, we can do, well, first do anything inside brackets if you can. The first bracket, is that going to be 1 or 12? 12. So that 0 exponent on B only refers to the B. So it's 12 times 1, which is 12. Then, nothing to do inside the brackets, but we've got exponents there. So we've got to square the 3. B to the 6 squared is B12. Now, if you want to do 3 squared in your head, absolutely, you go for it. I'm doing it in steps because I've been teaching for a long time. I know the common mistakes that students make. They forget about the 2. Think about it as you all want to be treated nicely. You all want to be squared. So 3 needs to be squared, B to the 6 needs to be squared. Everything in those brackets. So now it's really, so you might have 12 times 9b to the 12. And then final answer there is 108b to the 12. So you multiply the coefficients. together. Take a look at the next one. Here it's 3x squared, then brackets, which means that's multiplying, and you've got brackets raised to the exponent 3. So we've got to figure out what that is first. So 3x squared, I'm just going to copy out. Then in the brackets, it's going to be 4 cubed, x to the 6, y cubed. Remember that y is like y to the exponent 1. So 1 times 3 is 3. You may have gone straight away to 100, what am I? 64 times 4, 256. So you may have gone right from that to this. If this is in written response on your test next week or your quiz or whatever, you show, for sure you need to show some work. You don't have to show this step here, but certainly, well, one or the other you have to show, right? Typically, maybe you show the 256 right away, but one or the other. And so 256 times 3. What did I do wrong? Oh, I did 8 squared times 4. Okay, yeah, thank you. Sorry, 64. Isn't there a song, When I'm 64, or something like that? I don't know. Anyway, there's a song about being 192. Oh, okay, sorry. Okay, 192.
I hope there wasn't.
No, I think it's a Beatles song that When I'm 64 or something like that. Anyway, that's 8 and y cubed. So far, we haven't had any negative exponents, okay? But in C, we're given some parts of it with negative exponents, so it really depends what ends up happening. Notice here, we're just multiplying. There's no powers of power, so we have to multiply the coefficients together, and then the variables. So a to the negative 9 times a to the 6 is a to the negative 3, right? Negative 9 plus 6 is negative 3. Now we need to deal with that negative exponent. And just that part of it goes to the denominator. This negative 15 stays. It is not an exponent. Only time you flip things is when the little number is negative, the exponent. So this is negative 15 over a to the positive 3. So just like there, we multiplied the coefficients together. Now we are dividing the coefficients. Okay, it is not subtracting. So if I see negative 15 in this one, it's wrong. It is negative 2. And then x squared divided by x is just x. 2 minus 1 is 1. And y divided by y cubed is y to the negative 2. Or you might go straight away to negative 2x over y squared. If you notice that there's more y's in the denominator there than up top. So that really probably just one step, not really any work. Okay. 1 minus 3 is negative 2. Then positive exponents always, so that part only goes to the denominator. Okay. Oh, sorry. Okay. Next one, inside the brackets is a fraction. We can simplify that. There's common factors between 8 and 6. Bases are the same. So in here, you don't show decimals, so you reduce 8 over 6. What goes into 8 and 6? 2. So we divide by 2, we get 4 over 3. Then h to the 5 divided by h squared, we subtract the exponents. That's h cubed. Okay, so we're doing order of operations. We're doing inside the brackets first and then squaring everything. Now, with this, you could square everything and then simplify, but this will make it a little bit easier. So now, here's the deal. We have to square everything in there. So that's going to be 4 squared, h to the 6 over 3 squared. Now, if you can do 4 squared in your head right away, go for it. So that's going to be 16 h to the 6. Oops, I put a 2. Oh, gosh. Just a... There we go. Okay, or you could go 16 ninths h to the 6. Every single thing in the brackets gets squared. Now, actually, this next one is a little bit easier. There's no numbers, it's just powers. Multiply together up top. So you can do it in steps if you want to do the numerator first. And then divide. You can, or you can do it all in one step in this case. So here, 2 plus negative 7 is negative 5. Then when you're subtracting the biggest thing for dividing powers to the same base, you have to be good at your integers. So negative 5 minus negative 6. 1. Okay, it is not negative 11. Oops. Okay, it's just x. X to the exponent 1 is just x. Okay, now some work from yesterday's lesson with fractional exponents. First of all, take a look inside. Nothing you can do inside. I guess you could make the negative exponent positive, but I always wait till the end. Okay, because maybe there's other things that you're going to end up multiplying something else you don't realize. So in this case, all that we're doing is raising each factor to the 1/2. So negative 4 times 1/2, right? Power of a power, you multiply. Well, that's negative 2. You're taking half of it. 8 times 1/2 is 4. So now, this is the only part that has to go underneath. And so this will end up being b to the 4th over a squared. Just going to erase my y here because I can't see exactly. Okay. Okay, so this one, 2 brackets, nothing outside the brackets, so we're not doing powers of powers. So we multiply the coefficients, that's 21. And now we're multiplying powers with the same base of x. So we need to add the exponents. And they happen to be fractions, but what's nice is that they have the same denominator. So you're going to get denominator of 5 there. And so when you're taking 3/5 and adding negative 1/5, 3 minus 1 is 2. Okay? So that is in exponent form. Okay? Think about how you would show that with radicals. Again, what we were learning yesterday. Would I put, so this is the 5th root, right? I'll just put that there. Would I put the 21 inside or outside? Outside. It does not have a fraction exponent on it. If the brackets were around the whole thing, yes, you put it inside. But now this stays out, and this will be x squared, or x the squared outside the radical, either way. It just says simplify, so it didn't prompt you necessarily to show in radical form, but that radical form is simplified, so either way it would be fine. Okay. Next one, a division, where we have rational exponents. So we still have to subtract them, right? Take a look here. The 9 is in the denominator, and there's nothing that, no coefficient in the numerator, which means it's a 1. So this 9 stays here. It might end up being 1 over 9 h something, but right now we're going to subtract those exponents. Now, they don't have the same denominator. Yeah. So you might do some work on the side, but basically we have to take 3/10 and subtract 4/5. So we need a common denominator. 10 is the common denominator, yep. Lowest. 50 is a common one. 10 is the lowest. So I'm going to multiply top and bottom by 2. So that's going to be 3/10 minus 8/10. Yeah, it works out to be -5 over 10, which reduces to -1/2. So that's really quite nice, actually. Now, if it's -1/2 in the numerator, then this is going to end up being a 1 in the numerator, because we have to bring this down. And the 9 doesn't flip back up. The 9 is already in the denominator. So this is going to be 9, sorry, just a sec. 9. Why won't it change color? 9 h to the 1/2. So that is simplified. That's in exponent form or power form. In radical form, that would be 1 over 9 square root h. Okay, so either one of those. Okay? That's what is left. This is understood to be a 1 here.
Oh, because the h, okay.
Yeah. Can't put 0, then the whole thing would be 0. Yeah. All right. Lots of things to do in the next one. Within the brackets, nothing to do, nothing to do, nothing to do. But we've got an exponent on the first set of brackets. So that's going to be x to the 4, y to the 4 when I raise the whole thing to the exponent 4. Next one, I'm going to have -3 squared x to the 6, y squared. Close that, times 5x squared y. So I'm going to move my work for k down a little bit lower, just so that I don't squish it all in. Okay. Okay, so coefficient. There's nothing in front of the x to the fourth, so it's a 1. So then we have this multiplied by the 5. Well, what's negative 3 squared? It's 9. Just cross that out. So this is going to be 9 times 5 is 45 will be your coefficient. Nope, positive because negative 3 in brackets squared. It's positive. And then all the x's. Just do them all at once. So x to the fourth times x to the sixth times x squared is x to the 12. Y to the fourth times y squared times y. Is that y to the 6 or y to the 7? 7, because that is a 1 there. Okay, so y to the 7. And that's nice because there are no negative exponents, so you are done. Okay, in the last one there, first set of brackets, yeah, there's a negative exponent. I'm not going to worry about that yet because I've got other brackets that I have to deal with. So nothing to do in the first set, then nothing to do in that bracket, but it's raised to the exponent 3. So I'm just going to copy out the first bracket. And then in the second one, I'm raising everything to the negative 3. So that's going to be negative 3 cubed, m to the 9, n to the negative 12. Okay. So negative 2 times whatever negative 3 cubed is. So you could do another step, but remember I said you don't have to. So negative 3 cubed is negative 27 times a negative 2 is positive. Yep, positive 54. Then with the m's, negative 1 plus 9 is 8. And 3 plus negative 12 is negative 9. Okay? So only one factor that has a negative exponent, that's the only thing that we flip and it goes to the denominator. Okay? Yeah, you can sign out. Okay, so you can see that whole bunch to practice within the booklet. And then, of course, there's textbook questions. Scheduled, we're having a quiz on Monday, the review day. Okay. We're also going to have a little quiz today. Today.
Oh.
2 days.
I need a calculator.
Oh, no, it's a no calculator quiz. Okay? It's not going to be for a while. We have wise time today. So you're going to work. You're just going to work on stuff.
Wait, so we're done this year?